So here we have the ideal gas law using this equation here, PV equals nRT. And so we're going to take inventory, P, V, N, R, and T. Sample of hydrogen gas is the volume of, so here's my volume, 8.56 liters, at a temperature of 273 Kelvin. It should be in Kelvin as opposed to Celsius. If it were given to you in Celsius, you would convert it to Kelvin. At a pressure of 1.5 atm, calculate the moles. So that's my X of H2. Again, N is moles. Now R is a constant. It's going to be one of these three constants here, the 0821, the 8315, or the 62.4. How do you know which R to use? What proportionality constant to use that ties together pressure, volume, moles, and temperature? Well, the units have to match up. In particular, the units for pressure. Typically, we're going to be dealing with liters. Typically, we're going to be dealing with Kelvin. And when I say typically for Kelvin, I mean always in Kelvin. 273 K. That'll always be in Kelvin. Moles will always be in moles, obviously. But the ATM, the pressure unit, is what may or may not change. So here's ATM is our pressure unit, and so the number that I choose coincides with the proportionality constant that gives me my R value. So at ATM as opposed to kilopascals or as opposed to millimeters of mercury, we're going to be dealing with ATM, and so the number that I use will be the 0.0821 number. So that's the first step of taking inventory. The second step deals with the algebra, PV equals nRT. And so we're solving for moles, so I'll rearrange for moles, dividing both sides by RT to get me PV over nRT. And then the third step would be the plug and the chug. And now that I've taken inventory already, I don't have to go back and decode the words again or change the units or adjust the units. It's done already. So pressure 1.5 atm, volume 8.56 atm. R, that's where it takes a little bit of thought in terms of which R value do I use. And then T, 273 Kelvin. Push that into your calculator. 2 sig figs, thanks to the 1.5 atm gives me 2 sig figs, and you should end up with somewhere around 0.57 moles. So again, there's a couple of thinking points here. First, you want to think about the equation you're going to use. You want to get all of the units to match the unit for R. So if the volume was in milliliters, I'd convert it to liters. If the temperature was in Celsius, I'd convert to Kelvin. Then it's a matter of picking which R value I need to match the pressure units. Number two is asking you about STP. So STP is standard temperature and standard pressure. So these are your standard pressures and these are your standard temperatures, the 273 Kelvin. You can use any pressure you want as long as you get the R that corresponds to it. So ATM to ATM, kilopascals to kilopascals, and millimeters of mercury to millimeters of mercury. As long as the units match, it's okay. The only other trick for number two is that I give it to you in grams, and PV equals nRT, it needs moles. And so you're going to have to convert grams to moles. X line, drag down the unit, moles, HE, 1 mole is equal to 4.00 grams approximately. As I dig for that last decimal place. 3. And so this equals 1.499, I guess 2 sig figs actually, so 1.5 moles of HE, and that equals your N. That'll go into PV equals nRT. Thank you.